We're looking today at measured digits, also called significant digits. I prefer to call them measured digits because they indicate precision of the measurements that we've made. There are 5 rules to follow when looking if a measured digit exists or not. Any non-zero number is assumed to be measured. Sandwich zeros are measured. Zeros that begin the number are never measured. At the end of the number, if they don't follow a decimal point, they're not measured. But zeros that end the number and follow a decimal are actually measured. Again, the goal for these numbers is to indicate the precision of our measurements. Let's look at some examples here. So let's say I take the number 100.0. We look at this, we'll follow our rules. Any non-zero number is measured, so we know we've got 1. Okay, now what about sandwich zeros? Well, these 2 zeros are between this 0 and that 1, so we're going to look at them. 0 is a beginning number. There's no zeros that begin this number, so they don't count. Zeros that end the number and do not follow a decimal, okay, are not measured. Well, I've got a 0, but it follows a decimal. So this is the rule we're going to be using here, and any non-zero number is measured. So these are the 2 rules I'm looking at. So I'm going to count 1, 2, 3, 4. There are 4 significant or measured digits, okay, in this. Why? Because this 0 ends a number and does follow a decimal point. So that one's a measured digit or a significant digit, so is that 1. And then these 2 zeros are sandwiched, okay, in between. So that's how we apply these rules. Now again, it will take some practice, of course, in order to get really good at doing this, okay? Let's take a look at a contrary example, 100. Okay, we automatically know the 1 is measured, but these 2 zeros end a number, but they don't follow a decimal. The decimal point would be here if we wanted to write that for significant reasons. So this one only's got 1 significant digit, that 1 right there. These 2 zeros do not follow a decimal, and nor do they end the number. Now what if I have the number 100 point or a line on top? Either one of those tells us that this 0 is now a significant 0. It's been measured by my equipment. Therefore, this has 1, 2, 3 as an answer. 3 significant zeros. Because anytime you see a decimal point actually written in there or a line over the 0 at the end, then we assume that that's a significant 0. It's not just acting as a placeholder. It's actually been measured. Let's practice some others. So let's say I've got 0.005050. Again, we're indicating the precision of our measurement, which digits are assumed to be significant or measured. Okay, I've got zeros in the front. Okay, so automatically I'm just going to draw a little dash line. We know that they're not going to count as measured zeros. They're still important. They got to hold the place for these other digits. So placeholder zeros are the ones that are not significant. So that one ends a number but follows a decimal, so it counts. That 0 is between 2 significant digits, so the sandwich rule applies. So 1, 2, 3, 4. So there are 4 significant digits in this number. So hopefully that makes some good sense. We'll do a couple others to see if you can follow that. Okay? All right, let's go on to 100070. All right, let's try this one. All right, the 1 counts and the 7 counts. You know, by default, they're not 0 numbers. Now, these zeros are sandwiched between 2 significant digits, so they count, so we know that they're measured. And the last 0 here ends the number, but does not follow a decimal, so it doesn't count. So this one has 1, 2, 3, 4, 5 significant digits in it. All right, we'll try another one here. What about this one here? I have 0.050 grams. Okay. So I've got 0.050 and I'm putting unit grams next to that. Okay, this 0 here does start the number, so automatically discard it. We don't discard it, but don't count it as a significant 0. The 5 does count, it's a non-zero number. This 0, however, ends the number and follows a decimal point. So there would be 2 for this one. Hopefully the pattern is starting to make sense. All right, what about the number 0.0? Let's do 0.006, and that's all we got. Okay, well, there's no ending zeros. We know the 6 counts. These zeros begin the number on the left side. Those never count, so this one just has 1. Now what about the number 50,000? But I put a line over this one. So that tells me that line over there tells me that that 0 is a significant 0. Therefore, that one counts. That one must count because now it's sandwiched. So this one has 3. These ending zeros do not follow a decimal point. So they're assumed to not be significant or measured. Now remember, the line over this 0 tells us that that 0 is a measured 0. The other 0 there must be sandwiched. So that's how we do that. Okay, hopefully that makes reasonable sense. We'll practice, some more on this to help you understand it. But what do we use this for? Well, it's for rounding purposes. We have to indicate the precision of our measurements. Let's say I have the number 6.050 and I'm adding to that 2.10. All right, let's add that together. We're going to get 8.150. Now we need to round this number correctly. When addition and subtraction occurs, we round to the least decimal place. So I look at this one, we're out to the thousands place on this one, but the hundreds place on this one here. So this last digit here is the one we can round to. It's the hundreds place. I look next door. I do see a 0. Therefore, this stays the same. So 8.15. This is the place we're rounding to. I always look next door to see if this is 5 or larger. If it's 5, then I would have raised this up by 1. So it would have been 8.16. But I kept it a 5. Hopefully that makes sense for addition. Subtraction runs the same way. We round to the least number of total decimal places given. So since this is to the hundredths place, we must round to the hundredths and not include the thousands place there. Now what about multiplication and division? Let's say I'm calculating a density of an object that is 20.0 grams divided by 10 milliliters. Well, now we're going to round to the least number of significant digits. I look at this one. That 0 ends the number but follows a decimal that must be significant. That 0 is sandwiched, so 200.0 has 3 significant digits. This one's 10 point, so the 1 and the 0 both count because I put a decimal in there to indicate that that 0, which does not follow a decimal point, is significant. So I'm going to divide these two out, and my answer is going to be 2.00 grams per milliliter. Now I need to round this correctly. Okay. 2 significant digits is my least significant digits. I come up here, I can keep the 2 and the first 0, so 2.0 grams per milliliter. The last 0 I cannot include because it does not have the 0 over here in the original question. Okay, so there you go. We are only allowed to keep, in terms of our significant digits, only 2. Why? Because this one limits us to 2 sig figs. Do not include 3. So always go with the least. Hopefully that makes sense. We'll practice more in class. And of course, I'll let you ask questions for me.